So in this video, I'll basically cover cloud architecture, business benefits of cloud architecture, some examples of fundamental cloud architecture, and then two models in more detail, that is service load balancing and redundant storage. So why do organizations adopt cloud architecture in the first place? Traditional on-premise data processing comes with a lot of practical headaches. It's difficult to get as many machines as an application actually needs, difficult to get them exactly when they need them, and difficult to coordinate a large scale job across many machines, including recovering automatically if one of them fails. It's so hard to scale resources up and down as workload demand changes, and just as hard to get rid of that hardware once the job is finished. Cloud architecture solves this problem because application runs in the cloud. The physical location and the management of infrastructure is handled by the provider, not by the organization. Organization access simple internet facing APIs to industrial strength services that scale on demand. All the complex reliability, scalability logic stays hidden behind the cloud. This translates into real business values. Resources are used only as needed, sometimes seasonally, which means higher ROI and utilization as well. Businesses avoid large upfront capital spending on hardware, gain the flexibility to scale quickly to meet demand, and can redirect IT effort towards their core operations instead of managing infrastructures. For providers, it's also um, opens a new revenue opportunity since services can be sold flexibly as software, platform, and infrastructure. It's better for both ends. Um, so, some of the examples of cloud architectures are workload distribution architecture, which scales resources horizontally with a load balancer spreading requests evenly. Resource pooling architecture, it groups identical resources like CPUs or storage into synchronized pools. Dynamic scalability architecture automatically allocates or reclaims resources based on predefined scaling conditions. And comes elastic resource capacity architecture, which dynamically adjusts CPU and RAM on virtual servers based on demand. The other one is cloud bursting architecture, which stays on premise by default but bursts out to the cloud when capacity is exceeded. And the other one is elastic disk provisioning architecture, which uses thin provisioning so consumers are billed only for storage actually used. So now let's look deep into service load balancing. Service load balancing is a specialized version of workload distribution geared towards scaling cloud service implementations. It creates redundant deployments of a cloud service with a load balancing system dynamically distributing consumers' requests across these copies. There are two approaches. One uses a dedicated load balancer that intercepts requests and forwards them to multiple virtual servers. The other embeds load balancing logic inside the service itself. So, one instance can redirect requests to neighboring instances. This architecture is often supported by cloud uses monitors tracking consumption, resource cluster coordinating server groups, and resource replicating generating new service instances as demand grows. Now let's move forward to redundant storage architecture. Redundant storage is about resilience for cloud data. It introduces a secondary duplicate storage device as part of a failover system, continuously synchronized with the primary device through storage replication. In practice, under normal conditions, The primary device is routinely replicated to the secondary. If the primary ever becomes unavailable, a storage service gateway automatically redirects requests to the secondary, so consumers keep accessing their data without interruptions. One, con- One consideration is geography. Providers sometimes place the secondary device in different regions for cost reasons. This can raise data sovereignty concerns, and distance can also restrict which replication protocols are usable. To summarize, cloud architecture reduces the operational headaches of traditional infrastructure and improves scalability, utilization, and cost efficiency. We looked at several fundamental patterns and in more depth at service load balancing, which spreads workload across redundant service instances, and redundant storage, which protects data availability through synchronized failover. Thank you for watching.